Today we are going to start a new subtopic of chapter electrostatic, and the topic is electric potential at a point due to a point charge. In this topic we are going to derive the formula of the electric potential. Now before derive the formula of the electric potential, first of all we will derive the formula of the electric field intensity. Now here we have a charge, positive charge Q, which has the electric fields which is directed outward. Now here we have selected 2 points, point A and point B, and we will place a unit positive charge at point B, and this charge is moved from point B to point A. Since when the charge is moved from point B to point A, then it will move against the electric field. Okay, the distance from the charge Q, positive charge Q, to point A is RA, while the distance from the charge Q, positive charge Q, to point B is represented by RB, where delta R is the distance from point A to point B. As now we can say that delta R is equal to RB minus RA. So when the positive charge moves from point B to point A, then it covers a distance of delta R. Okay. So we can write it as delta R is equal to RB minus RA. Okay. Now as I have told you before driving the formula of the electric potential, first of all we will drive the formula of the electric field intensity. Now as we know that the formula of electric field intensity is equal to E is equal to 1 upon 4 pi epsilon naught multiply Q upon R square. So when the charge moves from point B to point A, so the question arises, which distance will we take as R in the formula of the electric field intensity? Will we take distance RA or RB? Now we know that the charge moved from point B to point A. So we will take their mean. We will take their mean, and that mean is equal to the R. Okay. So we know that R is equal to RA plus RB divided by 2. Now as we know that R, this equation shows that R is the midpoint. We will take R as a midpoint of RA, distance RA, and B, midpoint of A and B. RA is the midpoint of A and B. Okay. If R is the midpoint of A and B, therefore the ratio of R upon RA, one thing keep in your mind, if R is the midpoint of point A and B, then the ratio of R upon RA and RB upon R remains the same, which is the geometric mean. Okay, which is the geometric mean in mathematics. Now we know that R upon RA is equal to RB upon R. Then solve it by cross multiplication. R multiply R, R square, RA multiply RB, RA, RB. Now we have got the value of R square, okay, which is used in the formula of electric field intensity. R square is equal to RA multiply RB. Now put the value in the formula of electric field intensity. So the electric field intensity will become 1 upon 4 pi epsilon naught multiply Q upon RA RB. Now we have got the formula of the electric field intensity in that situation. Now we are going to use the formula as we have read this formula in potential gradient, that the electric field intensity is equal to delta V upon delta R. Okay, solve it by cross multiplication. Delta V is equal to minus E delta R. Okay, delta V means potential difference. As I have told you, since the positive charge will move from point B to point A, so in that situation point B is the low potential and point A is the high potential, and the potential difference is the difference from the high potential to the low potential, VA minus VB. Let's suppose the potential at point A is VA, which is high potential, and the potential at point B is VB, which is low potential. So the potential difference is high potential minus low potential, VA minus VB. Now in that situation, delta V, which is equal to VA minus VB, which is equal to minus electric field intensity RA minus RB. Now multiply this minus, it will become VA minus VB is equal to E RB minus RA. Now put the value of electric field intensity. So it will become VA minus VB, which is equal to, put the value of electric field intensity, Q upon 4 pi epsilon naught R square multiply RB minus RA. Okay. Now put the value of R square. Put the value of R square. We know that R square is equal to, as we have at R square is equal to RA minus RB. R square is equal to RA multiply RB. Put the value of R square. So it will become VA minus VB is equal to Q upon 4 pi epsilon naught RA multiply by RB. Then multiply the value of this RB minus RA. Okay. We can write this equation as VA minus VB is equal to Q upon 4 pi epsilon naught multiply RB minus RA upon RA multiply RB. Now break the LCM, okay, break the LCM. So it will become VA minus VB is equal to Q upon 4 pi epsilon naught multiply, break this LCM, it will become RB upon RA minus RA upon RB. Now here in this fraction, RB will be cancelled. This RB and this RB will be cancelled. While in that fraction, this RA and this RA will be cancelled. So it will become VA minus VB, which is the potential difference, which is equal to Q upon 4 pi epsilon naught multiply 1 upon RA. Since RB will be cancelled, so it will become 1 upon RA minus, here RA will be cancelled, so it will become minus 1 upon RB. Okay. Now let's suppose if the charge is moved from infinity, not point B, from infinity, or I can say that if the point B is located at infinity. If the point B is located at infinity and the charge moved from infinity to point A, so the formula will become, since as I have told you the point B is located at infinity, so the distance from charge positive Q to the point B is infinity. So here we will write that 1 upon, so here 1 upon RB, since RB is equal to infinity, so 1 upon RB is equal to 1 upon infinity. And one thing keep in your mind that 1 upon infinity is equal to 0. So the whole fraction, if point B is located at infinity, so the distance from charge Q, positive charge Q to the point B, which is called RB, is equal to infinity. And 1 upon RB is equal to 1 upon infinity. And one thing keep in your mind that 1 upon infinity is equal to 0. So put 0 in place of 1 upon RB. So it will become 1 upon RA. Okay. Now, it will become VA is equal to 1 upon 4 pi epsilon naught. It will become multiply Q by this 1. So it will become 1 upon 4 pi epsilon naught multiply Q upon RA. Okay. So we can write it as VR is equal to 1 upon 4 pi epsilon naught multiply Q upon R. So if we know the accurate position of the point B, we don't know the value of RB. So simple we can write R in place of RA. There is no need, if there is no point, if we don't know the location of the point B, we don't know the value of RB. So we can write simple as R in place of RA. So it will become VR is equal to 1 upon 4 pi epsilon naught and multiply 1 by Q, it will become Q upon R.